Welcome. Sometimes the simplest questions had the most incredible answers. Today, we're going to dive into a classic puzzle that starts out super simple but ends up somewhere beautifully unexpected. It's a fantastic look at how simple rules can create some seriously elegant results. Okay, let's set the scene. Picture this. You've got four dogs, and they're positioned at the four corners of a perfect square. Now, on the word go, every single dog starts running, and here's the rule. Each dog runs directly at the one next to it. So, dog 1 is chasing dog 2 is chasing dog 3 is after dog 4, and, you guessed it, dog 4 chases dog 1, closing the whole loop. And just to make this real, let's put some numbers on it. Let's say this square is exactly 1 mile on each side. And our dogs? They're really going for it, running at a steady 6 miles per hour. No distractions, just pure, focused pursuit. So, this whole setup really boils down to two main questions. And what's so cool about this puzzle is that one question is, honestly, it's almost surprisingly easy. But the second one, that's where things get interesting. Let's tackle the easy one first. So, what do you think? With all four of them running, how long does it actually take for them to all meet up in the center? I mean, they're not running straight at the center, they're chasing each other. So what's your guess? Is it going to be complicated? Well, here's the beautifully simple trick to this. Just focus on dog 1 chasing dog 2. Now, yeah, dog 2 is moving, but its path is always at a right angle to dog 1's line of sight. So from dog 1's perspective, dog 2 isn't actually running away from it, it's just moving sideways. That sideways motion doesn't make the gap between them any bigger. The only thing closing that 1 mile distance is dog 1's own speed. And since that gap is 1 mile, and dog 1 is closing it at 6 miles per hour, the math is just simple division. It takes 1/6 of an hour, which is a nice clean 10 minutes. See? Pretty clever how that works out. Okay, so that's the when. We know they meet in 10 minutes. But what about the how? I mean, they're obviously not running in straight lines toward the center, so what does their journey actually look like? This is where we get to the real heart of the puzzle. So, what is this path they're all tracing? Well, as it turns out, it's not just some random curve. It's a specific and, frankly, a beautiful and totally unexpected spiral. And this visual just says it all, doesn't it? They start in this rigid, boxy, 90-degree world of a square. But because of that simple rule, always chase your neighbor, they're forced to carve out these incredible smooth curves. The square basically just melts into this perfect spiral right before your eyes. Now, this gorgeous shape actually has a name. It's called a logarithmic spiral. But it also has another name, an equiangular spiral. And that name, equiangular, gives us a massive clue about why this exact shape forms. It's all about one angle that never changes. So, of all the shapes in the universe, why this specific spiral? Why not some other kind of swoopy curve? Well, the answer is hidden in the perfect symmetry of the setup and, you guessed it, a constant unchanging angle. Here's the key. Because of that perfect symmetry, the four dogs always form a square. It just gets smaller and rotates as they run. And because they're always at the corner of a square, the direction they're running, their velocity, always makes a perfect 45-degree angle with a line drawn straight to the center. And that angle, it is constant. It never ever changes throughout the entire chase. And that constant angle, well, that's the defining rule of our spiral. It's the law of physics for this little system. It literally forces the dogs into this exact spiraling path. They couldn't take any other path, even if they wanted to. All right, for all of you who are curious and want to peek behind the curtain at the mass, the formal proof is actually really elegant. We're not going to get buried in equations, don't worry, but let's just quickly walk through the three main steps that show us exactly why the spiral has to form. Okay, step 1 is all about changing our point of view. Instead of a regular XY grid, we use what are called polar coordinates, which are perfect for describing things that are spinning. This lets us break each dog's speed into two parts. Its radial speed, which is how fast it's moving towards the center, and its transverse speed, which is how fast it's moving around the center. Now, step 2 is where the magic happens. It's a really clever mathematical move. If you divide the equation for the inward motion by the one for the sideways motion, poof, the time variable completely cancels out. It just vanishes. And this is huge because it leaves us with a pure relationship that only connects the dog's distance from the center to its angle of rotation. And finally, step 3, we take that relationship and integrate it, and what pops out is this exact formula you see here. This is the mathematical signature, the very definition of a logarithmic spiral. So the math lines up perfectly with what we see. It's awesome. But here's where it gets really mind-blowing. This spiral isn't just some weird answer to a fun little math problem. It turns out this is a fundamental shape that shows up all over the place, connecting our little dog park puzzle to a much, much bigger picture. Take the famous golden spiral, right? The one you see in seashells and pine cones and even spiral galaxies. Well, guess what? It is the exact same type of curve as our dog chase spiral. They're both equiangular spirals. The only difference is that magic number, that constant angle. Ours is a strict 45 degrees. The golden spirals is about 73 degrees, an angle that comes from the golden ratio. They're basically mathematical cousins. And get this, it's not just a quirk of squares. This same fundamental rule of pursuit creates spirals in all kinds of setups. If you start with 3 dogs at the corners of a triangle, yep, you get a spiral. You can even generate a similar pursuit curve with just 2 objects. It's a truly universal idea in math. So what's the big idea to take away from all this? It's a perfect example of something scientists call emergence. You start with a ridiculously simple rule. Just run towards your target. But when you have a whole system of dogs following that rule together, this complex, beautiful, and highly ordered pattern, the spiral, just emerges out of the chaos, all on its own. And that really leaves us with one last big thought to chew on. If a simple chase between a few dogs can hide this much mathematical elegance, just imagine. What other profound, beautiful patterns are hiding in plain sight, generated by the simple rules we see in action all around us every single day?